Thanks for your time today, Alex. We'll start with a system design problem. I'd like you to design a system to scale Duolingo's DuoRadio audio content production using generative AI. Let's begin with the requirements. What clarifying questions do you have for me?
Thank you. I have a few questions to clarify the scope and constraints. First, what is the target scale for this system? Specifically, how many courses, languages, and episodes are we aiming to produce, and what is the user engagement goal? Second, what is the primary bottleneck in the current manual production process that we are trying to solve? Is it scripting, audio production, or something else? Third, what are the quality standards for the outputs? How is educational value defined, and what level of naturalness is required for the audio content? Finally, are there any key business constraints to consider, such as a target for cost or time reduction?
Excellent questions. The goal is to grow daily sessions from 500K to over 5M, scale from a handful of courses to over 25, and from roughly 300 episodes to over 15,000. The key bottleneck is the manual scripting and audio production, which is a labor-intensive process involving meticulous scripting, curriculum alignment, voice actors, and audio editing. Quality is paramount. Episodes must align with curriculum goals and sound natural, maintaining a high-quality bar. The primary business constraint is to achieve this scale while significantly reducing production costs, ideally by about 99%. That defines the scope well. Let's move on to the problem formulation. How would you frame this as a machine learning task? Please define the inputs, outputs, and the type of ML model you'd consider.
I would frame this as a two-stage machine learning system. Stage 1 is script generation. This is a conditional text generation task. The input would be structured curriculum data specific to a language and proficiency level, including well-crafted sentences, vocabulary lists, and exercises created by learning designers. The output would be a complete level-appropriate episode script that weaves the input content into a coherent, pedagogic narrative. The model for this would be a large-scale generative AI model, likely a large language model LLM. Stage 2 is quality filtering. This is a classification or scoring task designed to enforce our high-quality bar. The input is a generated script from Stage 1. The output is a quality score or binary pass/fail decision based on predefined learning and quality criteria. The model could also be a generative AI-powered evaluator prompted to assess scripts for naturalness, coherence, and grammaticality. This two-stage approach allows us to generate large volumes of content and then programmatically filter for only the highest quality scripts, ensuring the output remains excellent.
Okay, good. Now, let's discuss the data. What data sources would you need, and what key features would you engineer from them?
The primary data source would be Duolingo's existing learning curriculum. Initial experiments showed that generating scripts from scratch or with complex instructions yielded subpar results. Using the curriculum content itself, the well-crafted sentences and exercises already created by learning designers gives the model specific, high-quality patterns to follow. For feature engineering, I would focus on two key areas. First, language-specific curriculum data. For each target language, we would use the curriculum for that language. Using only English prompts proved less effective, so language-specific inputs are essential for accuracy and relevance. Second, learner session data. To standardize episode structure, I'd use session data to determine optimal placement and sequence of exercises, ensuring consistency and engagement.
You mentioned using curriculum data as input. How would you structure this data to serve as an effective prompt for the generative model?
I would structure the prompt to include key elements from a specific lesson, such as target vocabulary words, grammar concepts, and sample sentences. The model's task would be to synthesize these elements into a natural, coherent dialogue or story for the DuoRadio episode.
That's a solid data strategy. Now for the core of the system. The model. Walk me through your model development process from a simple baseline to a more complex solution.
The development process would be iterative, starting with simple baselines and building up to the two-stage system. The first baseline would be to generate from scratch using minimal input. This produced low-quality, misaligned results requiring heavy manual editing. The second baseline was automated translation of English scripts to other languages. This failed due to accuracy issues and incorrect proficiency levels began requiring extensive rework. Both baselines defeated the goal of scalable automation. The proposed solution is the two-stage Generate and filter model. Stage 1 uses a generative AI model prompted with structured curriculum data to create grammatically correct, vocabulary-aligned scripts. Stage 2 uses a second AI model as an evaluator and automated QA system prompted with criteria such as naturalness, coherence, logic, and grammaticality. Only scripts passing this filter move forward.
Why did you propose a two-stage model with generation and evaluation instead of a single, end-to-end model trained to produce only high-quality scripts?
The two-stage approach decouples content creation from quality assurance. This allows us to update evaluator prompts to refine quality over time without retraining the generator. It also lets us overgenerate and then select only the best outputs. This strategy ensures higher consistency and efficiency than relying on one monolithic model.
That's a well-reasoned modeling approach. Let's focus on evaluation. What specific offline and online metrics would you use to measure success?
I would use a combination of offline and online metrics. Offline metrics measure pre-release content quality. The evaluator model's performance would be judged on naturalness, grammaticality, coherence, and logic. These AI-driven assessments would be validated periodically by learning designers to ensure alignment with human standards. Online metrics measure real-world product impact. For engagement, we'd track daily active users, targeting growth from 500K to over 5M. For scalability, we'd track course coverage from 2 to over 25 and episode counts from 300 to over 15,000. For efficiency, we'd target reducing production time from years to quarters and achieving roughly 99% cost savings.
For online evaluation, how would you measure if the new content maintains educational value?
Through a /B testing, we'd compare a control group using manually created content with a test group using AI-generated content. The metric would be downstream learner performance, completion rates, and improvement in related lessons to ensure the AI content maintains the same learning effectiveness as the original.
Those metrics are appropriate. Now, let's talk about productionalization. Describe the high-level serving architecture you would build.
The system would be an offline, automated content generation pipeline consisting of several stages. Step 1. Script generation. The generator model creates batches of scripts for specific languages and levels. Step 2. AI-powered filtering. The evaluator model filters out scripts that fail quality standards. Step 3. Automated audio production. Approved scripts are sent to a text-to-speech system that generates lifelike voiceovers in the target language. Step 4. Audio assembly. Audio hashing retrieves standard intros/outros which are combined programmatically with the new content. Step 5. Deployment. Finished episodes are automatically uploaded and made available to users through the app. This pipeline would be orchestrated using an internal workflow builder platform, running end-to-end with zero manual intervention.
You mentioned text-to-speech. What are the main challenges and trade-offs when choosing a TTS solution for a multilanguage educational product?
The main trade-offs are between voice naturalness, language coverage, and cost. The system must produce engaging, lifelike voices across many languages, while keeping per-character costs extremely low to achieve our 99% savings target.
That serving design looks robust. Finally, what are the top challenges you anticipate in future improvements you'd consider?
The main challenges are achieving initial quality and maintaining it at scale. First, generating high-quality scripts early on is difficult. Naive approaches produced poor results, requiring a robust curriculum-driven prompt strategy to fix. Second, ensuring every one of the 15,000-plus episodes meets the quality bar is a continuing challenge. Even strong models can produce edge case errors, requiring ongoing tuning of evaluator prompts. For future improvements, I'd refine the learner experience, experimenting with episode length and exercise diversity for engagement. I'd also expand this methodology beyond DuoRadio. The same architecture could generate other immersive, context-rich learning experiences across Duolingo's ecosystem.
Excellent. To wrap up, I have a couple of quick fundamental questions. First, what's the difference between content-based and collaborative filtering?
Content-based filtering recommends items based on the properties of items a user liked previously, for example, suggesting more sci-fi movies to a user who likes sci-fi. It depends on item features. Collaborative filtering, in contrast, recommends items based on what similar users enjoyed. It identifies users with overlapping tastes and surfaces items they like that the current user hasn't seen.
And second, why is feature scaling important for models like logistic regression?
Feature scaling is essential because logistic regression uses gradient-based optimization. If features differ vastly in scale, say one range is 0,1 and another 0,1000, the larger scale feature can dominate the gradient and slow or distort convergence. Scaling features to similar ranges ensures smoother optimization and fair regularization, improving convergence, speed, and model stability.
Thank you, Alex. That was a very thorough explanation. We'll be in touch with the next steps.
Thank you for your time. I enjoyed the discussion.